Welcome to Maths with Jade. In this video tutorial, we will be doing index notation and the laws of indices. It's quite a big one, guys, so I've split it into two parts, and this is part one. Index notation is when we have something to the power of something else. For example, 3 to the power of 4. That 3 is called our base number, and that 4 is our index. The plural of index is indices, and they tell us how many times the base number multiplies by itself. So in this case, it's 4 times. So 3 times 3 times 3 times 3. In this series of videos, I will give you some rules, also known as laws, that will help you simplify and manipulate these indices. It should also help you understand them better. I will be revealing these laws to you throughout this video and part 2, so please corner off a section of your page and title it the laws of indices so you can keep adding to it and referring back to it when you need to. Law number 1 is our multiplying law, and we use it to simplify expressions involving indices that have a multiplication, such as this one. To simplify this, we need to make sure we have the same base. So I'm going to write this out in full, and I have 3 times by itself 3 times, and then 3 multiplied by itself 4 times. And then I'm multiplying those two together. Altogether, I have 3 multiplied by itself 7 times, which means this will simplify to 3 to the power of 7. Let's take a look at another one and see if you can spot a pattern. So I have 5 to the power of 10, which is 5 multiplied by itself 10 times. And then 5 squared, which is 5 times 5. Well, I'm timesing both of those together, which means altogether I have 5 multiplied by itself 12 times. So this expression simplifies to 5 to the power of 12. I think you should have picked up on the pattern by now. Let's look at just a generic multiplication for this. If I want to simplify this expression, what do I need to do with the m and the n? That's right, we want to plus them together. So this simplifies to a to the power of m plus n. And there's your first law. Please write it down in the section of the page you cornered off earlier. Let's jump straight to law number 2 then, the dividing law. Similar situation, but we're dividing rather than multiplying, so you still need to check that the two expressions have the same base. Rewrite this as a fraction because it is so much nicer to work with, and then write out the top and bottom expression in full. So I have 2 multiplied by itself 7 times divided by 2 times 2. Now I have a 2 times 2 on the top and the bottom, so I can actually cancel that out, effectively dividing by 2 times 2. And then I'm simply left with 2 multiplied by itself 5 times, which means this expression simplifies to 2 to the power of 5. Again, see if you can spot a pattern. I'm sure you will. Okay, a similar situation. I have the same base, that base is b, and I'm going to rewrite it as a fraction. Again, it's easier to work with, and then write the expressions out in full. I've got b multiplied by itself 6 times, divided by b multiplied by itself 5 times. Well, that's 5 b's on top and bottom that we can just cross straight out, and I'm left with b. So b to the power of 6 divided by b to the power of 5 gives me b to the power of 1. However, I would never write the 1 because there is no need, it's just b. I'm sure you spotted a pattern. So let's look at a generic version of this. What do I want to do with the m and the n to simplify this expression? Absolutely. So this will simplify to a to the power m minus n. Please add that to your laws of indices, and we will now look at law number 3, which is when we have indices in brackets. So here is an example of a situation that we want to simplify. So I have 4 squared to the power of 3. So I basically have an index to the power of another index. So if we look to what this actually means, it's 4 squared multiplied by itself 3 times. And then if we write each of those out in full, we have 4 times 4, 4 times 4, 4 times 4. It's multiplying together, so I have 4 multiplied by itself 6 times, which is 4 to the power of 6. See if you can spot a pattern with this one. You might have done already. So let's have a look at another example. So c to the power of 5 cubed. Well, essentially this is just c to the power of 5 times c to the power of 5 times c to the power of 5. And if we write that out in full, I have a lot of c's. Multiply them together and I get c multiplied by itself 15 times. Now, I don't recommend you ever write all of these out in the future. I'm just trying to illustrate the idea for you. So we have c to the power of 5 to the power of 3 gives me c to the power of 15. So here's our generic one. If I have a to the power of m to the power of n, how do I simplify this expression? What do I do with the m and the n? I multiply them together, so I have a to the power m multiplied by n. Please add that to your laws of indices. Law number 4 is slightly different. It's when we have something raised to the power of 0, and it's a very hard one to illustrate, so we're going to simplify this expression to help you understand. Now, to simplify this, I want to use the dividing law, so a to the power of 7 minus 7, which gives me a to the power of 0. Great, I have simplified this. But common sense would also tell me that anything divided by itself gives me 1. So a to the power of 0 must equal 1. Please add that to your laws of indices. And before moving on, I just want to highlight the magnitude of this. You can raise anything to the power of 0 and it gives you 1. Here's just a few examples. I'm now going to show you some examples of simplifying expressions with these 4 laws. Although skip to 4 minutes 45 if you just want to jump straight in with a task, you can always come back if you need to. For example number 1, we need to square both the parts inside the bracket. So we're going to have 3 squared, and then using our brackets law, y to the power of 4 times 2. And this simplifies to 3 squared is 9, y to the power of 8. Example number 2 starts to look a little bit scary, but if we look at just the top of the fraction, we can simplify it by using the brackets law, so multiply the indices. And then our bottom, the multiplication law, so plus together the indices. And this all simplifies to x to the power of 12 over x to the power of 5. And then using our division law, we can subtract the indices, and I get x to the power of 7. For example 3, we need to make sure we don't confuse our ordinary numbers with our indices. Let's leave the bottom as it is for now and simplify the top. Multiplication can be done in any order, so first let's multiply the 10 and the 3 and we get 30. And now multiply the z squared and the z and I get z cubed. We know that 30 divided by 6 gives me 5, so let's rewrite that fraction out again without the 30 and the 6 with just 5 on the top. Now if we're simplifying this, the 5 can just be left alone, and then it is a division, so we will be subtracting the powers. 3 minus minus 5. A minus and a minus make a plus, so my final simplified expression is 5z to the power of 8. Your turn. Use the first 4 laws of indices to simplify the following expressions. Pause the video now. Well done if you attempted all of those. Here are your solutions, and for the last one, because it's tricky, I've left a little bit of working out so you can see where you went wrong if you went wrong. Thank you so much for watching. This has been Index Notation and the Laws of Indices, Part 1 and Maths with Jade. Please do hit the like button if you enjoyed this episode. Subscribe to my channel, share this video and comment below. Do watch part 2 of this video for the remaining laws.